Okay, let's go ahead and jump straight into the lesson. We're in problem one. So problem one reads, the Jones family had 2 gallons of milk before breakfast. The family used 2 quarts of milk during breakfast. How many quarts of milk did the Jones family have after breakfast? Okay, so just like we were learning in the other video, we're not only adding and subtracting numbers, now we're adding and subtracting units of measure. In this case, it's gallons. Before we can subtract gallons from quarts, we need to convert gallons into the same unit of measure. So in this case, we're going to convert our gallons to quart. There are 4 quarts in a gallon, and there's 2 gallons, so we take 4 times 2, which gives us 8 quarts. So now we have the same unit of measure. Now we can subtract. 8 quarts minus 2 quarts equals 6 quarts. So the Jones family had 6 quarts of milk after breakfast, okay? Make sure you're labeling your problem as you go. Make sure if you don't know how many quarts are in a gallon, you can always look back in the lesson. Like I said in other videos, you can go ahead and make a little 3x5 card and put the information with you. That way you don't have to flip back and forth between your book and your pages. All right, next, number 2. Carol cut 2.5 inches off her hair 3 times last year. How much longer would her hair have been if she had not cut it? First of all, Carol, I don't know why you're measuring it, but we'll figure it out for you. All right, so we've got 2.5 inches that she would cut off every year, or 3 times during the year. So we're gonna take 2.5 times 3, okay? When multiplying mixed numbers, we need to change the mixed number into an improper fraction. So we go ahead and do that. 2 times 2 is 4, plus 1 is 5. So my mixed number is changed into an improper fraction, 5 over 2. My whole number I'm going to represent as 3 over 1, okay? 3 over 1 is 3, okay? So now I can multiply my numerators. 5 times 3 is 15, 2 times 1 is 2. And then I reduce. So 2 goes into 15 7 times evenly, okay? So 2 times 7 is 14 with a remainder of 1. So we've got 1 over 2. So your final answer should be 7 and 1.5 inches. All right, next we are going to do the prime factorization of 54 over 135, okay? So first I took my numerator, 54, and I was looking at the video on the other side, and I realized that it's really small. So I'll read it out to you, but I do want you to make sure that you have this written, okay? So I took my numerator, 54, and then I found the smallest prime number by which I can divide it, which is 2. So 54 divided by 2 is 27. Then my next smallest prime number that I can divide that by is 3. So 27 divided by 3 is 9. The smallest prime number I can divide 9 by is 3. So 9 divided by 3 is 3. And the smallest prime number that can be divided by 3 is 3. And 3 goes into 3 one time. So this is the prime factorization of 54, 2, 3, 3, 3. And so I've written that there as my numerator. 2 times 3 times 3 times 3 is the prime factorization of the numerator 54. Now, prime factorization of the denominator, 135. Go ahead and take my, the smallest prime number. Oh, by the way, my watch. You guys remember when I broke this in class and I was like really upset? I finally got a band for it, and no, I got it. Anyway, has nothing to do with class. Okay, 135. I find the smallest prime number by which I can divide it by, and that is 3. So 135 divided by 3 is 45. And the smallest prime number that I can divide 45 by is 3. So 45 divided by 3 is 15. Okay, the smallest prime number I can divide that by is 3. So 15 divided by 3 is 5. And the smallest prime number that goes in evenly into 5 is 5. So 135, the prime factorization of the denominator is 3 times 3 times 3 times 5, represented here. So this is your first part of your problem. This is your first part of your answer. And then the next part of your answer, if you need to pause the video and write that down, go ahead, because we're about to do a bunch of stuff to it. Your next part is we're gonna cancel out some of these, okay? So I've got a denominator 3. 3 goes into 3 one time. 3 goes into 3 one time. And 3 goes into 3 one time. okay? So all the 3's get canceled out. So now for my numerator, I have 2 times 1 times 1 times 1, which equals 2, and 1 times 1 times 1, which equals 5, and that's the next part of the answer. 2 and 1/5. All right, on to problem number 7. Okay, we have what is the area of the parallelogram? Okay, now remember when multiplying or when trying to find the area of a parallelogram, it's not length times width, it is base times height. And here we're given the information that we need. We have 25 meters as our height and 24 meters as our base, okay? The height and the base create perpendicular lines. Those are lines at right angles. Okay, so we take our measurement, 25 meters times 24 meters. Here we have the same units of measure, okay? So we multiply the numbers, 24 times 25, and that gives us 600. But we also are multiplying our units, okay? And so our units multiplied together are represented by m squared, okay? Remember, we're not writing SQ anymore. We're representing the square with our exponent of 2. Exponent of 2. All right, number 9. Some rectangles are trapezoids, true or false? If you go back to lesson 78, and you look at the characteristics of quadrilaterals, we see that a trapezoid is a shape with only one parallel side, whereas a parallelogram, which is a rectangle, needs to have 2 parallel sides. So in this case, it's false because rectangles have 2 parallel sides and trapezoids only have 1. A trapezoid cannot be a rectangle. So number 9 is false. And any question that, anytime you get a question like that, you can always reference back to lesson 78 where it talks about the shapes, or any other lesson that you need to reference back to. All right. This actually took me forever. I couldn't figure it out. Well, I had it figured out, but I was having trouble representing it, but I finally got it. Okay, so we're putting numbers in order. We're arranging 1/2, 1/5, and 0.4, okay? Important when comparing fractions and decimal, you probably want to change everything either to a decimal or into a fraction. And for me, I changed, since there was only one decimal, I changed the decimal into a fraction. So 0.4, make sure you see the decimal, 0.4, 4 is in the 10th place. So as a fraction, it's represented as 4/10. 4/10 reduces down to 2/5, okay? So now I have 3 fractions. I have 2/5, 1/2, and 1/5, okay? So my unit, the line segment I drew goes from 0 to 1. My half is represented as this middle point right here. I broke it up into 5 parts, 1, 2, 3, 4, 5. Okay, here's the halfway mark. 2/5 is represented right there, and 1/5 is represented right there. This kind of gives you a visual representation of which number is the smallest and which number is the greatest. So the number closest to, the fraction closest to 0 is obviously the smallest. So 1/5, then we have 2/5, and 1/2. So this should be your order. If you can't see it, I'll write it down. 1/5, 2/5, and 1/2. Oh, not 1/2. Oh, I'm sorry. I did that wrong. We're putting the actual number. So 2/5 is 0.4 represented, and then 1/2. Sorry about that. All right, so 1/5, 0.4, and 1/2. I made the mistake of not answering the question that was actually in the book. The book is asking to arrange those certain numbers, 1/2, 0.4, and 1/5 from least to greatest. And I was still using my fraction when I had to be using this. So 1/5, 0.4, and 1/2 should be your final answer for problem 11. Okay, we're looking for the missing number for number 13. So you're not given the final answer here, but I'm going to show you how I got that, obviously. We've got 4/25 and blank over 100, or in your book, it's blank. Okay, so I see what I had to multiply 25 by to get 100. in this case, 25 times 4 equals 100. So whatever I do to the denominator must be done to the numerator. So 4 times 4 equals 16. And that's how we found the missing numerator for number 13. Okay, our final answer, or final question, we've got 10 minus 0.1 in parentheses times 0.1. Obviously, you know, as soon as you see the parentheses, the operation within the parentheses needs to be performed first. Okay, so we take 10 minus 0.1. Okay, I wrote it down here. I shouldn't have canceled it out, sorry. But I've got 10.0, okay? I put the 0.0 to hold my tens place value, and then I subtracted it. Now, I can't take away 1 from 0, so I borrowed from the 10, and I got a 9. And then I subtracted 10 from 1, which is 9, and then 9 minus 0 is 9, so 9.9. So 10 minus 0.1 equals 9.9. Now I can multiply it by the 0.1. So I have 9.9 times 0.1. I go ahead and multiply it. 1 times 9 is 9, 1 times 1 is 9, okay? And now, in order to place my decimal point, I counted how many decimal places there were. So 1, 2. And so I placed my decimal point 2 places. So 0.99 is the final answer. If you have any questions about the work for the even numbers, leave a comment, give me a call, shoot me a text. But please, 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 if you need any help at all, please let us know. Also, if you need any material for any of your other subjects, which I don't think you should need any other materials, everything is on the online quizzes. But if you need paper or pencils or a bag of Takis, I'm just kidding about that one. Well, if you really want a bag of Takis, let me know. And we'll try to get it to you as soon as possible. All right, guys, thanks for watching.